Welcome. In this e-learning module, I shall make you understand how to design the spring for the stripper. Remember, we had designed the spring for the strip pusher. To design the spring for the strip pusher, we had used this three-step process. Step 1. Calculate the push force. Step 2. Calculate the spring constant and deflection. Step 3. Spring selection. Let's get started with Step 1. We shall calculate the push force. In the previous e-learning module, we had calculated the stripping force. The stripping force FST is equal to 14,126.4 newtons. The push force is equal to the stripping force. This means we need to apply a force of 14,126.4 newtons on the stripper plate to strip the sheet metal, which gets stuck to the blanking punch after blanking. Let's plan to use 4 compression springs on the stripper plate. Observe the springs are mounted on the stripper plate with the support of shoulder bolts. The push force per spring will be 14,126.4 newtons divided by 4, equal to 3,531.6 newtons. So, each spring should apply a force of 3,531.6 newtons on the stripper plate. Now let's calculate the spring constant and spring deflection in the second step of the spring design process. Measure the distance between the top plate's bottom surface and the top surface of the stripper plate. This is where the spring shall be mounted. The measured distance is 60 mm. As the press tool is being designed in the closed condition that is at the bottom dead center, this is the compressed length of the spring. To strip gets stuck to the blanking punch after blanking. To strip the sheet metal from the blanking punch, we need to move the stripper by 5.15 mm. 3.15 mm is the strip thickness. 1 mm is the punch entry into the die. And an extra 1 mm to make sure the sheet metal is positively stripped from the blanking punch. So, 3.15 mm plus 1 mm plus 1 mm is equal to 5.15 mm. This is the stroke of the stripper plate. The space available for mounting the spring is compressed length plus the stripper stroke, which is 60 mm plus 5.15 mm, equal to 65.15 mm. Remember, when we are physically assembling the spring, the press tool is in the open condition. The open condition is the same as the condition of the press tool at the top dead center. So, the space available for mounting the spring is 65.15 mm. Generally, when we mount the spring is preloaded by 5% to 10% of its length. For example, a spring of 10 mm is mounted in the space of 9 mm, so that the spring is always compressed by 1 mm. This compression is called preload. We can calculate the total length or free length of spring. The total length or free length of spring is equal to space available divided by the preload amount. 65.15 divided by 0.9 gives us the total length or the free length of spring is 72.4 mm. Generally, springs are available in steps of 5 mm length. Hence, we can finalize the total length or the free length of spring as 70 mm. Note with 70 mm as the total length or the free length of spring, the preload is 7%, which should be just okay. As the strip is stuck to the blanking punch at the bottom dead center, we need the push force of 3,531.6 newtons at the bottom dead center. The spring constant can be calculated by dividing the push force by the spring stroke. Spring stroke is the difference between the total length and the compressed length of the spring. 3,531.6 newtons divided by 10 mm, we get the spring constant as 353.16 newtons per millimeter. Hence, we need to select a spring with spring constant 353.16 newtons per millimeter or more. Now let's calculate the maximum spring deflection. Maximum spring deflection can be calculated by dividing the difference between the total length and compressed length by the total length. The calculated value of the maximum deflection is 14.28%. Hence, we need to select spring with allowable deflection 15% or more. Now let's select the spring in the third and final step of the strip pusher's spring design. We have already calculated the free length of spring as 70 mm. The spring constant should be more than equal to 353.16 newtons per millimeter. The maximum allowable deflection of the spring should be more than or equal to 15%. By referring to any spring catalog on a spring manufacturer website, select a spring, matching these criteria. I recommend you search on the internet and choose the compression spring. I have selected the compression spring. The inner diameter of the spring is 17.5 mm. The outer diameter of the spring is 35 mm. And the spring constant is 441 newtons per millimeter. With this, we have successfully designed the spring for the stripper. That's all in this e-learning module. Thanks.